All right, class. So for part two of this demo, we're going to be covering memory management. So memory management, I know it gets confusing. So storage is when we're talking about actual places where we store files, where we save those files. Memory, however, um, is always referring to the processing power that a computer has. So they sound similar in terms of hardware, right? It is about storing data, although memory is all about ephemeral data, right? Data that you need for quick processing. Um, it's essentially why your computer runs so quickly because it has significant RAM or read random access memory. So what does that look like? What does memory look like on a computer, right? How can we look at the memory performance of a computer? Well, if you're on Windows, this is obviously different on Mac. I definitely encourage you to Google, right? How would you do this on Mac? But essentially, we're going to look at the processes running on our computer. In Windows, it's pretty simple. You can do Control Alt Delete and then go to Task Manager, and then here you go. You
Hello,
can also
class.
welcome to this week's demo on managing
Whoops.
file systems and system memory.
One sec.
Uh, Looks like a video started playing. All right, so uh, once you're here on your task manager, which you can access through your search bar, you can put task manager as well. Another way to get there. These are all the processes. Remember, this is a vocab word for this week. These are all the processes running on your computer, the different applications pretty much executing tasks. So I have Google Chrome, I have a few tabs open there. I have Adobe. I was working on some PDF files, Microsoft Word. I have my recording software, Spotify, my VirtualBox manager here. And you can actually see how much memory it's taken. So here we can see 42% of my memory is being used up right now. And the grand majority is being used by my VirtualBox machine, which makes sense, right? I'm running an entire, like baby machine, right, inside of my computer, a virtual machine. So that's going to take quite a bit of memory to do. So we're giving some of that memory to that computer. And in fact, I did give it 3,000 megabytes of virtual memory. So it is using that up at the moment. So yeah, if your virtual machine kind of makes your computer go a little crazy, you can always crank it down so that it's not as powerful in terms of memory. So yeah, if it's being a little taxing on your computer, it's probably because you gave your virtual machine too much power, too much memory, too much computing resources. Of course, we have background processes here too. So I've used this example in my 101 class. So the apps, these things are running. These are the ones you control, the ones you decide on, right? So it's like when you move your body, right? It's when you talk. Those are things that you think about that you are doing willingly. Now, your body also has a lot of background processes, right? Your digestion, it happens on its own. Your breathing happens on its own. Your blood pumping through your body happens on its own. Well, computer needs to do a very similar thing. It has background processes. So in order for everything to work right, for the screen to show, for your mouse and keyboard to work as they should, for the software, right, to all work at the same time, right, this multitasking, we need background processes. So you can see 140 different processes here just to make my computer work as it's supposed to. Not all of these are crucial, right? I could definitely end some of these and nothing would happen. Others might be a little bit more catastrophic. So definitely you don't want to be closing these, without being careful. But yeah, as you can see here, these are all the processes on my computer. So we have our GUI here, right, for viewing our processes. Well, if we're on Linux, we should have a CLI version of this, right? How can we look at what's running on our computer using Linux? Well, we're going to go over the commands we went over on this week's slides. All right, so if we're going to go ahead and kind of do the same thing we did just now on Windows, but on Linux, we're going to have to run a few commands. So on the slides we cover free. You could also do free-h to get a more human readable format. There's also vmstat but perhaps the most similar to that task manager is going to be the top command. Make this big. Extremely, extremely useful to see what's eating up your memory in your machine. So here, right, I'm not really running much. I just got the terminal open. So I do have my shell open. That's taking up some memory. So my bash shell, that's probably what we have open right now. If I go ahead and open Microsoft, or sorry, Firefox, that should start eating up some memory as well. And you can see here, 10% that memory, 13%. It's not going to be consistent, right? As these programs, execute tasks, right? The memory is going to spike up and down. But yeah, if you want to do the exact same thing on Task Manager, all you need to run is the top command here on Linux. So we have our percentage of memory that it's using, the percentage of CPUs. So those are the cores. Cores are basically computing chips, whereas memory is total memory. Um, and then we have these other, so we have PID, so that's the ID of the process. So each process actually has an ID. So some of these really important processes, right, the background ones that we saw just like on Task Manager, they're going to have very low PIDs. Those are the system, right, running essential processes so that the machine actually works, right? And then here we get kind of some global stats. We have 209 tasks running, not too different, right, from the Windows. We have one app running right now, which is our shell. 208 are sleeping, zero stop. There's no zombie processes. So zombie means like you try to end the process, but it just won't die. That definitely happens sometimes, especially when I'm doing Docker, running things on Docker. Some of my containers sometimes get stuck as a zombie process. And yeah, here we have CPUs being used, zero point 0.1 of a CPU, not too much. And then we can see how much is free, right? So top definitely the most useful out of those system memory management commands. And here you can see everything that's running. So definitely useful when you're debugging, right? When you're running software, when you're making sure that, hey, does my machine even have enough resources, right, to do what I want to do? For example, if you're running a server, um, does the computer have enough power, right, to run that server to handle all those requests? And this is why Linux is really popular for really particular use cases like web servers, right? Web servers are computers, right, that handle the requests we make, for example, on the internet when you want to see a website, when you want to see data. Linux is kind of perfect because you can customize it for that particular use case. Whereas Windows is really more a general operating system, right? For like, personal computing users, just like Mac, right? You're not going to be really it is possible, right, to develop on Mac, but you're gonna see some really high tech or scientific development on a Mac computer. Linux, however, is kind of a blank slate. You can use it for whatever you want. You can really make the Linux OS really thin. So if you don't have that many resources on a particular hardware, Linux, you can throw away all the stuff you don't need, right, and keep only what you want and what's essential. So this is why we use Linux, right, for um, a lot of the more advanced technological use cases, right? Now, if you're just a personal user, right, of computers, then of course Windows and Mac are just fine. But when you're trying to solve really specific problems, right? If you're a server computer, if you're working on a really limited hardware, right, limited machine, limited computing resources, then Linux is kind of the way to go. Again, you can eliminate things that you don't need. Whereas Windows, right, it's a really big, really bloated operating system because it's all about making it look nice, making it useful to users, right? But Linux is not about making it pretty, it's just about making it work. And that's why the CLI, right, is such an important tool in Linux. So now that we've kind of been exploring more and more about Linux, hopefully it's kind of making more sense as to when we use Linux, right? Why is Linux so useful? And why do most of us, right, in our personal lives don't use Linux? Because we're not solving these really specific computing problems. Of course, right, if you're working for a company, some kind of tech organization, right, enterprise, then of course you're probably going to be using Linux at some point. All right, so let's see. All right, so how can we actually manage these processes, right? Because if you're in the task manager, you can actually end processes by just using the GUI. So you can end the task by doing a right click. Just went ahead and deleted Spotify, or not deleted, but closed it, ended the process. For example, Microsoft Word, and the task there. There you go. This is particularly useful, right? You've probably already used Task Manager if the process just, you try to close the app, but it's frozen. Well, same goes here. We're going to open up a new terminal, and we're going to run PS. So it's going to show me the running processes. So of course we have two of them. And it's probably for my two terminals here, right? Two different processes. How can I figure out which ID is for which, right? Well, for this terminal, just a little trick. You can actually run echo. Echo, remember, it's going to print out something. If you do $, it's going to print the current PID. So then the other terminal must be 4229. So if you do kill 4229, we'll see what happens. 4229, 4216. Oh, okay, my bad. So actually, I'm not going to be able to kill that terminal because it's only going to show me the processes from the perspective of this terminal. So if I do PS again, the only one that I'm actually showing is 4216 here. All right, so what if I do want to kill this terminal, right? Well, let's do kill 4216. That didn't actually do anything, right? That's sometimes where you need to employ some flags. So if you do a -9, that's going to be the force flag. It's going to force the process to be terminated. And this should close my window. And there you go. It did indeed close. So if you get the PID of the process, you can go ahead and terminate it. So that'll be everything you need, right, for today's lab, right? We covered partitions, we covered formatting, we covered some simple memory management, just how to keep an eye, right, on the memory statistics. Extremely useful, right, if you're a Linux system administrator, or maybe if you're just using Linux, right, for a particular use case, right? Remember, if you're working in a certain, tech company, maybe you're doing some data science, maybe you're doing some scientific analysis, right? It's very useful to know some of these Linux commands, right? You're not going to use every single one, right, unless you become a Linux administrator. But for the most part, right, all of these skills can be useful, especially, right, memory management. I think that's a big one. File system, kind of navigating the file system, another extremely useful one. Packages that we covered last week, extremely useful, right, because packages kind of give your Linux system uh, kind of a more specific use. So, like, for example, if you're doing scientific analysis, right, you might install some packages for that. But in any case, right, everything you need for this week's lab, um, we covered in this demo, covered in the slides, so you should be ready to go. We'll cover the lab instructions in the next video.